Okay, so we're going to talk about complex numbers, and in order to talk about complex numbers, we have to talk about imaginary numbers. And imaginary numbers came about because of this question right here. What is the square root of -1? I can't have square root of a negative number equal to a real number, because the whole idea of the square root is if I multiply two numbers together that are the same, that's the square root. Well, if I multiply two numbers together that are the same, you're never going to get a negative. So they had to invent another system. It's called the imaginary number system, I. Well, this is an important result. This is a highly important result. This is actually probably more important for most of what we do, is that I squared is equal to -1. So where this becomes immediately helpful to you is in simplifying radicals with negatives now. We can use imaginary numbers to go a little further. So square root of -4, most of your calculators are going to flag that as an error. But the reality is I can rewrite that as the square root of 4i, because square root of a negative gives me an I. Then I simplify the radical. Square root of 4 is 2. So the square root of -4 is 2i. When I go down to the next one, I see square root of -12. I don't even care about the 12 right now. I'm going to rewrite that as square root of 12i. Then I'm going to simplify the 12. And then I'm going to simplify the radical. So that ends up 2 square roots of 3i. Next one down, square root of -3 times square root of 2. I am going to suggest you do it this way. This is the safe way. As soon as I see that negative, I'm going to slap an I on the end. Okay? So square root of 3 times square root of 2 gives me square root of 6i. This next example is highly important, because if you just go, oh, I got square root of -5 times square root of -7, I'm just going to multiply those together, that's not going to work. Okay, and this is one of the few exceptions in math where you cannot follow a typical rule. This is a special case. Square root of -5 is square root of 5i. Square root of -7 is square root of 7i. Got those highlighted. Now I simplify a little more. Square root of 5 times square root of 7, square root of 35. I times I is I squared. And now you have to remember what I squared is. I squared is -1. Substitute that in, and the whole radical is negative. So that's a quick intro to imaginary numbers. Complex numbers look more like this. 3 plus 5i, -7 plus 2i, 0 minus 5i. You have a real part, you have an imaginary part. You put them together, you get the complex numbers. So every number you work with is technically complex, okay? Because it's either imaginary or it is real. So if I look at 8, 8's purely real, but I could write it like 8 plus 0i, which we typically don't do. Purely imaginary, -2i. Well, I can write that as 0 minus 2i. Complex numbers. Another term that you've heard before is conjugates. So the conjugate of 3 plus 5i is 3 minus 5i. The conjugate of -2 plus 6i is -2 minus 6i. You're just changing the sign in between, just like we did with radicals. And that should kind of make sense because I, remember, is the square root of -1. So technically it is a radical. We'll deal a little more with that later. Operations with imaginary numbers. And I just say here, just combine like terms. And honestly, that's all you're doing. Okay, when I start class, I might even just start with one of these and I can tell you what I is. But you can see here, you're adding the like terms. So I get 3 minus 2 is 1. 7i plus 11i is 18i. Okay, escalating here a little bit. We're going to multiply 3i into that binomial. So I distribute that in, and I get 12i minus 15i squared. Remember, I times I is I squared. But what is I squared? Yep, -1. So minus 15 times a -1 turns into a positive 15 plus 12i. So pause this and work through that yourself. Make sure I'm doing it right. Make sure you're following it. The only thing different from what you've been doing in algebra so far is the fact that I squared is going to turn into -1. Okay, if I want to multiply two complex numbers together, like 2 plus 5i times 3 minus 7i, FOIL it. Okay, first, outer, inner, last. And that's what I have going on here. First times first gives me a 6. Outer is 2 times a -7i is -14i. Inner is 3 times 5i is 15i. And the last is 5i times -7i is -35i squared. I have it all written out here. But if you're doing it in your head, this is what you're coming up with. combine your like terms. So I have a 6. Negative 14 plus 15 is 1i. And this is going to turn into negative 1. So eventually it turns into a positive 35. 35 plus 6 is 41 plus I. So that is your complex number. Here's another one. Here I'm multiplying conjugates, and this is one skill that you'll use. When I multiply the conjugates, just like when we're doing it with radicals, you're going to see that the middle terms with the i's disappear. And when I'm done, there'll be no i's left, and you'll just have a real number, 41 in this case. So pause it, go through that, make sure you can do it. Okay, this is kind of the worst kind of thing we're going to do is simplify. If I'm trying to divide two complex numbers, well, you're going to multiply the top and bottom by the conjugate, just like you did with radicals. And I made up a fairly nasty one here. The conjugate of negative 4 plus 7i is negative 4 minus 7i. So I have to FOIL out the top. So negative 12 minus 21i plus 20i plus 35i squared. And the bottom gives me a 16. It's going to give me a negative 49i squared. 28s are going to go away. Bottom becomes 65. I keep simplifying the top, step here, step there, just working through it. And I end up with negative 47 minus I over 65. Generally speaking, we typically want to write it like that as two fractions.